All right, so howdy. This is, I guess, the common end of a particular section. So here's the kind of mini test that I created for these polynomial expressions. It's kind of meant for grade 11, I guess, when you're starting to study functions. As usual, I will always put the downloadable link to this. I'll put it in the show notes below so you can download it if you like. You'll see the timestamps there as well for each question. I do encourage you to try it on your own, and then you can come back and take a look at the solutions as you're going through this. Okay, so let's get started. So question number 1. So factor the polynomial. Now I've created this one, and it's not the nicest one to start, but I think factoring is such a common thing in grade 10 that you do. So I wanted to push this a little bit further and try something, okay, so a little bit harder. So notice this is not like a typical small factoring where you're just dealing with quadratics. You know, you have a degree of 4, which is on the 2x to the 4 term. So trying to factor this whole thing out is not the easiest thing to do. And now, what process would you take to do that? Well, one of the first things that I always like to take a look is if I can get something out. So get the greatest common factor out of the entire thing. And just looking, so not all the terms have an x, but I guess 2 is factorable from all of them. Okay, so I can take out the 2, which is going to make my life a little bit easier. Now, I don't know if it's going to help me much, but let's take a look. That's what we're going to have left behind if I take the 2. So that's the factoring out of that. Now, commonly, so students will get stuck in here because they'll be like, okay, well, I can't really do anything else, and then they'll just leave it. Maybe they'll just get 1 out of 5 marks or something like that. Now, let's try to think kind of outside of the box. If you can't see any factors right away, you typically try to organize yourself and think of grouping things. You know, is there a way of being able to group certain terms so that you can factor something out? I do see, you know, right here, I do have a quadratic, okay? So if I just take that on its own, and I'm going to try to see here if I can factor this out. Now, I don't want to deal with the negative 9, so maybe what I'll do is I'll do this, x to the 4 minus, and so if I take out the negative, I'm going to get 9x squared minus 6x, I guess plus 1. That's going to be there. So the 2 still stays behind. Now, right here, so what can I do? I mean, what might help, and again, what I'm looking for is kind of patterns, right, in factoring. Now, I can see that this is x to the 4. I can see that this is a minus. So if this entire thing here, if this is some kind of a perfect square, then we're going to have a difference of squares between the x to the 4 minus something which is a perfect square. So maybe this is a perfect square, and I can see, so 9x squared is, you know, 3x, okay, if I take the square root of that. The 1, well, 1 is just 1, okay, so I'll have that. The square root, now this is, so it's minus, so right here. So let's take a look and see, you know, is this fully, it is actually, right? Because you're going to have 3x times the 1, which is 3, and you're going to have 2 of them, which is going to give you this negative 6x, okay, because of the negative. So that's great. So what I have now is I have something like this. And this is definitely helpful because I can factor this out. And so between here, so between this, and because this is negative, I have a difference of squares. So what I can do is I can say x squared minus, all right, so the 3x minus 1 multiplied by x squared plus, that's the difference of squares, 3x minus 1. And I have this. Now I can simplify, so I can bring in the negatives in, okay, so, you know, that I can do in this way, so x squared minus 3x, this is going to be plus 1, so I'll have this, and then I have x squared plus 3x minus 1. and that's the 2. So those are your factors. Now you might think, okay, well maybe the x squared minus 3x plus 1 is also factorable, or the the x squared plus 3x minus 1. So these two terms, maybe you can factor these out. So now unfortunately, okay, so they're not perfect squares at all. I mean, they are quadratic, but as I can see here, so we have the x, so for example, I'm going to try to factor, so the 1 and the 1, that's just going to give me 1, and I can't really nicely factor that out into this, okay, so we're not going to get a very nice factor. And just for kind of completeness, you know, you can do within here your quadratic formula. So if we have negative b plus minus the square root of b squared minus 4ac over 2a, you know, you can double play this and then check what this is actually going to give you. And so in this case, you know, what would we get? Just to see, so I'm going to get 3, so plus minus, and then under the square root, so b squared, so that's going to be 9 minus the 4, okay, so that's what I'm going to have here, and then divided by, so this is going to be just divided by 2. Now that works out pretty well because I have 9 minus 4 underneath there, but it's going to give me 5, and then I'm not going to have a very nice solution to those roots. All right, so it's going to give me 3 plus minus, and then it's going to be a radical there. So I can't nicely factor this out, and then you can try the same thing here, and you're going to run into the same issue right there. All right, so that's what it's going to give you. Okay, so I'm going to remove this, which means, so delete, that this is pretty much as far as I can take this factoring. All right, so that's a very mean question, but it kind of allows you to see, okay, so what can you do in terms of factoring these things out? So those are going to be your 3 factors for that entire thing. Okay, question number 2. Question number 2 has 2 parts. Now this one's going to be a little bit simpler because it says expand and simplify the following expressions. So we're just doing expansion, we're not doing any factoring in here at all. So we're going to be doing the distributive property as we're going through. Now, so let's take a look. Okay, so this is part A. So I have y squared. And then, I mean, I can bring in that y, so let me do that. We're going to get 3y squared and then minus 2y. All right, so that's just simply distributing the y inside there. And now if it asked us, I mean, it says simplify, so this is really as simple as we can kind of make it. The only thing is, notice that I do have like terms here, and that would be 4y squared minus 2y. Now it doesn't tell us to factor this at all, just says simplify, so we can leave it like that. But in case you want to, you can take out the 2y out of here, and that's going to give me just 2y right there. And then it's going to give me minus 1, and that's what you will have kind of if it needed to be factored. But I mean, this is okay, if it's expansion, it's not asking you to factor, it just asks you to expand, so this is good enough. So that would have been for part A. Definitely much simpler than that first example. For part B, which is this one, for part B, so what we have is, so let me kind of take this out. So I have in that first factor, so x squared plus 2x. Now in that second factor, which is this, oh, I see this 3x and then minus 4x. So I actually collect those, so 3 minus 4. So that's going to be just negative x minus 2. That's what we're going to have there. Now before I just start expanding this entire thing, so you can do that. This actually has... Notice, so we have an x and an x here. So I can, let me factor this out for the moment. So x plus 2, that looks a little bit nicer. Now out of here I have a negative and a negative. So let me take out the negative. And that's going to give me x plus 2 in here as well. So that's pretty neat. So So I have x plus 2 and then x plus 2 again from those, which is super neat. So I have negative x, and really this is going to be x plus 2 squared, right? That would have been as simple as it possibly can be. Now, as it does say expand, so we can try to expand this as well. So I like this, this is much neater, but if we need to expand, then so be it. All right, so if it's an expansion, I'm going to take these two, so this one, all right, and this one, because looks like it's a perfect square, which is kind of neat. And from there, what we have is, so that's just x squared plus 4x plus the 4. And that again, so that comes from, okay, just distributing across right here. You can check that for yourself. So x squared plus 2x plus 2x plus 4. And that's how we got that. And then the negative x. So if you wanted to expand this out in full, and that's going to give me negative x cubed minus 4x squared minus 4x. So that's kind of an expanded form. And this one right here was kind of all out in factored form, which so those two are good to go. All right, so that's question number 2, and I hope that makes sense to you. All right, let's take a look at question number 3. In this third question, so again, we have, I guess, A and B, and it says simplify the following rational expressions, state restrictions. Okay, so, well, restrictions are given on denominators, right? So we don't want to have a denominator of 0. So we'll do those restrictions. And the first thing I guess we'll do, since we have to simplify, okay, so let's try to factor these out first. And so that's the first one right here. So let's take the numerator. I can see that it has a common a. I'm going to take that out of there. Okay, so that's my numerator. Let's see if I can do... Now the denominator also has... Yep, it has an a. And it gives me a squared plus a minus 2. All right, so that's the a's. So my first restriction... Well, a cannot be equal to 0. All right, so I'll do that, okay, before these two cancel. So that would have been one of my restrictions if this was a function in a domain and where the input was a. Now, for this bottom denominator, I don't know if I can. I'm just kind of looking at it. Okay, so can I factor this out? All right, so, well, 1 times 2 is, well, 1 times 2 is 2, so the multiplication of 2 and then the addition, okay, so that's going to be a squared. So I'm going to decompose that a. Well, what's going to work is, it's going to work as 2 and negative 1, right? Because if you add those, it's going to give you plus 1, and if you multiply, it gives you negative 2, which is what we want. I'm going to do that. Let's put that in here. And now, so if I decompose this, so let me take out the a, it's going to give me a plus 2, take out the negative 1, and that's going to give me a plus 2. All right, so that means in factored form, that denominator there is going to be a minus 1, a plus 2. That's that. And from there, so what's left over here is really this right here. That's what we have right there. Now, so here's the other set of restrictions. We've already had a cannot be equal to 0. Now we can complete this. So a cannot be equal to 0. It cannot be equal to 1. That's coming from here. It's going to make that 0. And it cannot be equal to negative 2. And that's coming from here. So that's that. Now we can go ahead and cancel. So this will cancel with that, and that's going to be a very simple 1 over a plus 2. Okay, so that's pretty simplified, and then here are your restrictions. Okay, so those ones we have to be aware of. Now, if you simplified the whole thing, then you might think that the only restriction was just a cannot be equal to -2. So be careful. The restrictions always apply before you start to cancel. That's part A. Now, part B, this one looks more complicated, but we'll see, maybe it's not. This is part B. So we have a quadratic on top. And in the denominator, I can already kind of see. So here's a difference of squares right there. So the denominator will be nice. So x minus 1, x plus 1, that's the difference of squares. And 2x plus 1. That's going to give me all the restrictions actually. So x cannot be equal to 1, -1, and then from here, it cannot be -1/2. Now, why? Okay, so again, so please remember, so we cannot have this equal to 0, right? So if we bring this over, that's -1, 2x, divide both sides by 2, and that's why those are the restrictions. Now, the same thing is for these. All right, so we have restrictions out of the way. Now, the top, meaning the numerator, right here, well, clearly this is not a perfect square, so it's not very nice. Now, can I decompose that in any way? So I have the 6 times 2 is 12. Everything's positive, so now two numbers multiplied together, that give me 12, and added together, okay, so that's going to be 4 and 3. Because they add together to 7, and then they multiply to 12, and they're both positive. So we can decompose this. So it's going to be 6x squared plus 4x plus 3x plus 2. And now, so let's take out, okay, so what do we have? I can take out 2x. I'm going to group these two together. It will give me 3x plus 2. It should be that. And then, so here we actually have that. So we're only going to take out 1. Okay, so that's grouping these. Because we want these to be in common. It's going to be our common factor. We're going to take out. And that's what we have on top here. It's going to be 2x plus 1, 3x plus 2. So does anything cancel? Yep. Notice this. Cancel that. So that's gone. Now that we have our restrictions, all right, so what does that give me? Let me get rid of this. I have space, and I'm going to write it down. So this finally simplifies to the following. And x minus 1, x plus 1. All right, so that would have been the end of question 3. Let's take a look at question 4. For this question, so we want to be able to add and subtract the expressions. So we're going to have to find common denominators. And, well, we'll try to simplify. Now, it does say state restrictions, so we will try to do those restrictions as well. So here's the first one. Let's maybe bring it down here, blow it up a little bit. Okay, so, well, first, okay, so in terms of restrictions, so right here, so x cannot be equal to -1 because it's going to make that denominator 0, which is not what we want. Now, this also happens here, actually. And then with this one, so x cannot be equal to -3/2. And that, again, so it comes from, so taking that factor, setting it to 0 and seeing. So if you bring this over, it gives me that, dividing both sides by 2. And that's how we get that. We did that over here as well. So those are my restrictions that you have. So those you can make sure you understand those. Now, in order to be able to add and subtract anything, we need a common denominator. Well, the common denominator, so notice these two are actually in common. So I'm going to set the denominator to be these two factors. Those are the only ones we need, really. And now what does that make? Okay, so this right here, this x is going to get multiplied by 2x plus 3. That's our minus. And then this 3x is going to get multiplied by actually nothing, because those two factors are already there. And now the following express simplify. Okay, so I mean, this is you know, you're pretty much done here. The only thing is, I guess it says simplify, so let's try to expand this out. Okay, so I'm going to collect all my terms. So that's going to give me 2x squared plus 3x minus 3x. That's in the numerator. Notice 3x minus 3x cancels. And so that's going to just leave me 2x squared. And in the denominator, I will leave it as x plus 1 and 2x plus 3. So that's actually a pretty nice rational polynomial that we have here. All right, and then those would have been the original restrictions that we had. They actually do stick around at the end. So that's part A. Now for part B, let's see if that one is going to be nice or if it's going to be kind of ugly. Let's take a look. This is part B. So again, so you know, in terms of your denominators, I'm just looking here, So, well, the first one, so this is 2x divided by, this is x minus 1. So again, difference of squares. So those ones are okay. So my restrictions, so I won't be able to have x equal to -1 or 1. So those ones coming from there. Now this right here, I mean x squared plus x, so we can't really factor this out in any nice way. This is not a perfect square. It's clearly not a difference of squares, because there's no subtraction at all. I'm just looking at it in terms of decomposition. Can I decompose this? Well, 1 times 1 is just 1, so I can't really decompose this either. Does this even have any? I guess it probably doesn't. All right, so I mean, since it's kind of a test, you know, I don't know. I mean, you can obviously use decimals to see if you have zeros, but if it's a test, okay, so you know, I'm not going to try to use decimals on this occasion. So what I'll do is I'll use the quadratic formula, kind of bring it back. So negative b, again, plus minus. This is b squared minus 4ac all over 2a. And what I'm interested in is actually the radical. So that's going to be, so under the radical, b is 1. So 1 squared minus 4. And okay, well, that's the problem. So you're going to have a negative under the radical, right? So 1 minus the 4 is going to be that. So that means we don't even have zeros here. So this is, we can't factor this in any way. We're not going to get anything real as our zeros. So that means we're kind of stuck here. So it's going to be plus 4 and then x squared plus x plus 1. All right, so this is what we're going to have here. And okay, so delete. Now notice most of the time, let's say if you're running out of time on tests or something, you can show the teacher that, you know, the restriction, so for example, this restriction, this cannot be equal to 0. But we know it will not be equal to 0 at all. There are no zeros for this one. We just did it by the quadratic formula. So we know that there's no roots at all to this. So we're actually going to be okay. But I mean, if worse comes to worse, you can always write this to let the teacher know. that you understand that you would have to restrict that. You know, let's say if you were running out of time. Now for us, we actually don't need it because we just checked it. So I can't even factor this out in any way, which is going to be a problem for us now because this is not going to be very pretty at all. So that means if we want to be able to add this together, so we have, these are going to be my three factors. So x minus 1, x plus 1. So that's going to be my lowest common denominator here, which is not a very pretty one. And then in the numerator, so what we're going to have, so if we take this, so my 2x, so I have to multiply this by x squared plus x plus 1. Here's my plus, and then 4, and this is going to be x minus 1 and x plus 1. So that's what we would have to do. All right. Now it does say, you know, simplify. So let's try to simplify this, at least the numerator. I mean, this one, you know, you can leave the factors as it is. But here, if I bring all of this in, you can, you know, I'm going to work all of this out and in kind of fast forward fashion for you, and then you can see what happens, okay? All right, so let's try it. What is that going to give me? All right, so that's kind of collecting the like terms and expanding it, bringing it all together, okay, if necessary. Now we can, I guess, factor out the 2. So notice these are all even numbers within here, 2, 6, 2, and 4. But that's probably as far as we can kind of take it in terms of simplification. And that's it, okay, so for this one. All right, so we'll see you in a future video. Thanks for watching. Bye, everybody.